In this lesson, we're going to look at how you can identify whether a molecule is polar or nonpolar. What we know is that a covalent bond is formed when elements share electrons back and forth. We can further classify a covalent bond as being either polar covalent or nonpolar covalent depending on how the electrons are being shared. In a nonpolar bond, the electrons are shared equally between the two elements. But in a polar bond, the electrons are shared unequally. So there ends up being an asymmetrical or uneven distribution of electrons. That causes one end of the bond to be partially positive and the other end of the bond to be partially negative. When you have that unequal distribution and that one end being partially positive and that one end being partially negative, you have what's called a dipole. So just as you can classify an individual bond as being either polar or nonpolar based off of the way that the electrons are distributed, you can also classify a molecule as being either polar or nonpolar. So polarity in a molecule is going to be determined by whether the electrons in the molecule are equally or unequally distributed. So when you put water and oil together, those two things are going to separate due to polarity. Water is a polar molecule, oil is a nonpolar molecule. Polar and nonpolar molecules do not want to interact with each other. All right, so now let's start to define the differences between a polar and a nonpolar molecule. So in a polar molecule, you have an uneven or asymmetrical distribution of electrons throughout the entire molecule. So what happens is one end of the molecule is partially negative and the other end of the molecule is partially positive. So there ends up being an overall net dipole to the molecule where one end of the molecule is partially positive and the other end is partially negative due to that uneven distribution of electrons. In a nonpolar molecule, the electrons are equally distributed or symmetrically distributed throughout, so there is no overall net dipole. There isn't a partial negative or partial positive side to the molecule. All right, so you can go through, complete this check for understanding slide. So first one's fill in the blank. The electrons in a nonpolar molecule are distributed evenly, so there's no dipole. The electrons in a polar molecule are distributed unevenly, so there is a dipole. Select which statement best describes a molecule with a dipole. So one side is partially positive and the other is partially negative. Identify if each molecule is polar or nonpolar. This first one is polar. I can see that because you have one end being partially negative and the other end being partially positive. Carbon dioxide, I don't see those two different ends, so it ends up being a nonpolar molecule. So now what we need to look at is how to identify whether or not a molecule is polar or nonpolar. We're going to start off with looking at polarity in molecules. If that molecule only has two elements in it, so there's only one bond. So if the bond is polar, then the molecule is going to be polar as well. If the bond is nonpolar, then the molecule is nonpolar as well. So if there's only one bond in the molecule, whatever that bond is, that is also what that molecule is going to be as well. So we'd use the electronegativity difference to figure out if the molecule is polar or nonpolar based off of what that bond is. It gets a little bit trickier when you have a molecule with more than two atoms in it. So if a molecule has more than one bond, polarity is determined by the type of bonds and the geometry of the molecule as well. So a molecule will be polar if each bond is nonpolar, but there are non-bonding pairs on the central atom, or if the bonds have different polarities and or there are non-bonding electron pairs on the central atom. A molecule is going to be nonpolar if each bond in the molecule is nonpolar and there are no non-bonding electron pairs, or if each bond in the molecule has the same polarity and there are no non-bonding pairs on the central atom. What we're going to do in the next few slides is we're going to go over three rules that take this slide and simplify it in order to help you figure out if a molecule is polar or nonpolar based off of the Lewis structure. So the first rule is if a molecule has a non-bonding pair or pairs on the central atom, the molecule is most likely going to be polar. So if you were given the Lewis structure of NH3, I see there's a non-bonding pair on that central atom. So I'm going to classify this molecule as most likely being polar. The reason for that is when there's non-bonding pairs on the central atom, that generally causes the molecule to take on a three-dimensional shape that causes an asymmetrical distribution of electrons. A key thing to understand is you can't see this uneven distribution from the Lewis structure itself. It's something that comes into play when you're looking at the three-dimensional geometry the molecule takes. But if you draw a Lewis structure and there's a non-bonding pair or pairs on the central atom, that molecule is most likely going to be polar because it's going to cause it to take on a three-dimensional structure where the electrons are going to be asymmetrically or unevenly distributed. What Rule 2 states is if the central atom is bonded to different atoms with different dipoles, the molecule is most likely going to be polar. So if we're looking at this example, carbon's the central atom, but there's chlorines and hydrogen bonded to it. So that means there's most likely different dipole moments with different dipole strengths. And in the three-dimensional structure, that's most likely going to cause an uneven or asymmetrical distribution of electrons. So if you look at the Lewis structure and there's different elements bonded to the central atom, you most likely are going to have a polar molecule. The last rule states is if the central atom contains no non-bonding pairs and the central atom is bonded to the same exact type of element, the molecule is going to be nonpolar. So for CH4, we have carbon, there's no non-bonding pairs, and all of the atoms bonded to it are the same exact element. This is most likely going to be a nonpolar molecule. When both of those requirements are met, in that three-dimensional structure, the molecule is most likely going to have a symmetrical or even distribution of electrons, and there is going to be no overall net dipole moment that's going to happen. So what I want you to do is go through and look at these three Lewis structures, identify if each molecule will be polar or nonpolar, and then state which rule you used in order to classify the molecule. So for NCl3, it's polar. There's a non-bonding pair on the central atom. For CCl4, it's nonpolar. There's no non-bonding pairs on the central atom, and all of the atoms bonded to the central atom are the same. Please make sure if you're using Rule 3 to describe it, to justify it, you have to state both parts. There's no non-bonding pairs on the central atom, and all of the atoms bonded to the central atom are the same. Last one is going to be polar. I see that there are different types of elements bonded to that central atom. So this slide summarizes everything we've looked at today for the polarity of molecules. The first key thing you have to understand is the difference between a polar and a nonpolar molecule. A polar molecule in its three-dimensional structure is going to end up having an uneven distribution of electrons. That causes an overall net dipole in that molecule where one end of the molecule is partially positive and the other end is partially negative. In a nonpolar molecule in its three-dimensional structure, the electrons are evenly distributed, so therefore there is no overall net dipole. This difference is going to make a really big impact when we're looking at the types of intermolecular forces that molecules can interact with. So you need to be able to identify if something is polar or nonpolar. Just remember, if the molecule only has one bond, whatever that bond is, that's also what the molecule is going to be as well. So if there's only one bond in the molecule, you would take the electronegativity difference for the two elements and then use that to then identify if the molecule will be polar or nonpolar. But if the molecule has more than one bond, you have to look at the Lewis structure in order to classify polarity. If there's non-bonding pairs on the central atom, polar molecule, different elements bonded to the central atom, polar molecule. But if there's no non-bonding pairs on the central atom and all of the elements bonded to the central atom are the same, that's going to be a nonpolar molecule. You can't see the polarity from the Lewis structure. We're simply using the Lewis structure as kind of a hack to figure out whether or not that molecule will be polar or nonpolar in its three-dimensional structure.